Okay, let's talk about some of the advanced concepts in Rust. Let's see what is super trait. So, yep. Um, so if super trait is something like um, we can create a trait from another trait, so that when we implement our new trait, we have to implement the old one, the parent one as well. So it's kind of some kind of inheritance. So let's see the example we have in the Rust example um, book. So if I have a trait like person and he needs to implement the function name, take self and return string. So this is what the person trait is. And if you want to define a trait again, student, and when you define a trait student, you want them to inherently implement name as well, basically person as well. So you can just do this. So students we are deriving from person, and student will have a university, and this also take self and return a string. So we define a student trait inherited from person, and let's define a trait programmer. Programmer who has a favorite language. So we need to always define this favorite lang function, which will take self and return a string. So now we have a trait computer science student. So definitely he will be a programmer. Oh no, he needs to be a programmer. So he need to implement programmer trait as well as the student trait, and he will have a cheat username. Now let's see what will happen. What will happen when we define a computer science student. Let's now let's have a function computer science student greeting. He is a student, and we can give the type as a reference to dynamic reference to science student. So that means it's a trait. We can only do dynamic way to give that type. You have to give that reference. So ampersand dyn science student. So when we have this and we are returning format, we can format the string like this. um, my name is bracket and I attend this university, and my favorite language is my JIT username is this. So this is what we need to print. For that, the first one is name. So we know that computer science student will implement the person, so definitely he will have a name, so we can call that function, comma. Now we need to give the university definitely will be there because he's a student. Computer students inherits should have both programmer as well as student, so he should have implemented this universities. And language, since computer science trait inherits from programmer as well as student, so yeah, the two, this way we can make sure that we inheriting from two traits. One is from student, one is from programmer, so he should have a favorite language. Yep, that. And come science student, definitely he need to implement this JIT username, so that also he will have. Okay, so this is what does. Now let's see, we can just compile this. Cargo build, here it's building. Cargo run, yeah, it's running but it's not printing anything. Let's build something in the main. Okay, um, let's build a student as new student. For that, we need to create a structure new student and has name, university, language, and username. So define this and implement a new method for this, which will accept all these parameters and create a new structure, new student. So with that, we are creating a new student here. So we created a student 1, and we know that we want to implement new student for um, science student. This is a computer science student trait. So all these structures or objects implementing this computer science student, they should have programmer and student. So we are pushed to implement um, programmer and student. So if I am just commenting this, I just implemented the student, but I am commenting this, and we will see what is the, yeah, computer science student just need JIT username, right? That's what we have written here, but it's inherently need programmer and student. So I did not implement student trait for new student. Let's see what is the error we are getting. Cargo build. Yeah, it's saying new student trait student is not implemented for new student. So I'm implementing student for new student, but let's comment programmer and see whether this is required or not. Yes, programmer also required. So I am uncommenting that. So we have programmer and student. Now we need student need person, right? Um, that's what we set up here. So students superset is person, super trait is person. So person needs to be implemented. So let's see whether compiler will give us that error if we are not implementing this. Yes, student for new student, person is not implemented. So we have to implement person. Person just need a function called method called name, and which accepts self, and we are just returning self dot name and clone to make sure that it's on this string owns that string. So self dot name in this case will be Naveen, and self dot university will be UBC, self dot lang will be Rust, self dot username will be this username. So with that we can pass ampersand student1 reference to this student1 to this function which actually accepts anything which can implement this trait science student, computer science student. So ampersand dine, because it's a reference trait cannot does not have a size, so it's dine and it's a reference. That's a reference only we are passing, but it can interpret student dot name will get that call that method, so we'll get name here. So basically we can pass this ampersand student1 because new student now implements computer science student trait. With that, let's run this. Person is not implemented. Oh, it's not saved. Yes. So my name is Naveen. I think UBC, my favorite language. So it's got all the uh, variables, and we made sure that new students new student implements computer science student. So anyone we can pass this new student to external users to implement, so they inherently need to implement all these traits. That's where we get the control. If you are building a library for new student, you can control the external users stating you need to implement all this traits in order to call this student computer science student greeting method function. So yeah, basically we are inheriting these um, traits. So person student inherits the person trait. So all students need to implement person as well. Programmer is independent, but computer science needs to implement programmer as well as students. So we can do multiple uh, traits inheritance, super traits. So that's what I need to cover. Um, so that's what mentioned in this Rust by example. You can refer this super traits. So same thing they have implemented here. Um, Now let's go to this fn trait. So this is a standard library trait std ops. It's under ops module. Fn is a trait. Let's read. Instance of fn can be called repeatedly without mutating state. This fn is not confused with function pointers, is not to be confused with function pointers. For function pointers are different, we will talk about that later. Fn is implemented automatically by closures which only take immutable reference to captured variables or don't capture anything at all. Yeah, so if we are implementing a let closure clo- closure equals x and print, sorry, just pipe and just print this is a closure and you just need to close this, so it will return this format it should return a string. That's all we want. Okay, it's return a string. Basically it's return a string. So this is automatically implementing this uh, trait fn trait. You can see that. So yeah, that's what they mentioned here. And this fn trait inherit um, needs to implement this fn mute. So it's implement this fn mute, and fn mute implements fn once. So you can see this three fn related traits. And for example fn once, so if you have a function consume with relish f function f, and f implements this trait fn once and return string, and you can basically call so let's do string x. So we are getting a string x, consume and return x, move, and yeah, this is just a closure. And we can call this function with this consume return x closure, and it will consume it, and f func consume its captured variables. Yeah, this will be captured since it's moving, and you cannot use x anymore. Consume delicious. Yeah, attempting to invoke function again. Yeah, you cannot invoke function again. This is done. So let's see. Yeah, let's see this run consume delicious. So where is it? Yeah, if I want to call this again, then it's a problem. Control X. Yeah, value moved here. So if you are using this, oh, it's automatically moved here. Consumer list value moved here. Let's take ampersand. Percent. Expected string found ampersand string. Oh yeah, here ampersand string. And I want just fn. Or lifetime parameter dash static. Oh, annotated with lifetime here. Remove lifetime annotation. Oh no, that won't work. Hmm. And then let's do one thing. We can do copy. Mm, let's x equals Naveen. This ampersand str, right? So and comment this. Then do this. Then it should copy basically. Copy and same. Oh, this is not string. This is ampersand str. If I'm not wrong. Run. Oh, expected named lifetime parameter. Function consume ampersand f. Alternatively, really? Okay, help. I'm expected named lifetime parameter. Okay, named. Okay, help functions return type contains a borrow value, but there is no value for it to be borrowed. Consider using ampersand, sorry, dash static lifetime, but this is uncommon unless you are returning a borrowed value from a const or a static. Okay. Where fn ampersand static, instead you are more likely want to change the argument to be borrowed. Okay, this is what they are suggesting. Oh, just get this function pointer and then just this is enough. Let's run this. What? Instead you want to be borrowed ampersand ampersand. Alternatively, you can want value. Is it allowed? I don't think it's allowed. Okay, Okay, I just want to pass the ampersand. To be closure, return str, return ampersand str. Okay, again back to the same. Expected named lifetime parameter our fn dash static str. No, why ampersand? Okay, this is what most likely you want to do. No, this is something wrong. Let's keep going. For dash static. Yeah, okay. This dang good. Yeah, it's printing the same thing. So if I do this, will it work? No. Yeah, it's moved here. Where is where it written moved? Expect okay. Uh, expected ampersand string. Yeah. Dash. It's not on. It's no need to keep this on one. Oh, it's returning the ownership back to this. So this is gone basically. You cannot. Yeah, closure fn once because it moves value here. Ah, okay. Yeah, it should be fn once. You cannot call it again because value moved. Hmm. Okay. Yeah, that's what. That's what. So what happened is this string is an owned value. You're giving the ownership to x, and x is basically moved here, but we didn't give move. This is a, it should give a reference, and we are calling the reference to the closure, but we are moving the value out of it. That's not good. It won't allow. So if I give move, then it should be fn once. Yeah, yeah, it's moved. Value is moved. You cannot call it more than once. Yeah, closure should implement once. Exe. Print consume. Yeah, function moved due to the call fn once. The value implements fn once, which causes to be moved. Okay. Yeah, it's not that comes. Really? It's not because of that. Yeah, it's giving reference. It's reference and is calling, so value got moved. That won't agree because we given ampersand and you are taking it out value. So that's not good. Yeah, fn once. If you are moving and taking out value, it should be fn once. Yeah, compiler is making sure that. Yeah, that's what fn wants. So yeah, what we were discussing is how we came to here. Fn trait, right? Fn traits. Yeah. So it's basically inheriting from fn mute. It should implement fn mute. Fn mute is call fn mute required method. It's inherently implementing. So we don't need to worry this pipe thing, and the compiler automatically implements that. Is there any way to see that? Yeah, let's see what this. Oh, no way to see that. It's, yeah, we cannot navigate the code. Cargo expand will do. Yeah, I'll leave that. Fn once, and Fn once implements type output required function is called once. Oh, so if you are, then this should be mutable also. What is fn mute? Fn mute, you have something, yeah, you are mutating. Calling a mutably capturing closure. Okay, you are mutating, so it's implementing fn mute. Yeah, this function. So in this example, we are defining a mutable x equal 1 and add 2 to x. So we are mutating x with adding 2, and this closure we are calling twice, passing to this do twice. Here we have to mention that it's a mute function. Is that required? It will be a mute function. Run. And the third print println comma x. Yeah, 5. So it was 1 and defined a closure. We are doing it twice, so that means we are passing 1 when this is calling, it's adding 2, so it will be 3, and 3 plus 2 is 5. So that is understandable. So but why this mute is needed? Oh, not mutable, cannot borrow as mutable. Okay, here when we are calling, it's changing the value, so we need to make sure the function is mutable. If I give fn, will it work? Closure is fn mute because it mutates the value x. Yeah, you cannot restrict. Fn should implement fn mute. That's what I don't understand. Um, See, it inherits from fn once. Fn inherits from fn mute. Well, fn implements automatically by, oh, it's implementing only this. If you need to implement fn, you need to implement fn mute. Yeah, fn mute will be implemented, but it won't be calling that. Yeah, system will calling only call It says ignore that the other one. Fn mute and Fn ones are super traits of Fn. Any instance of Fn can be used as a parameter for Fn mute or Fn once is expected. Use Fn as a bound where you want to accept a parameter of function like type and need to call it repeatedly and without mutating state. Example, when calling concurrently. If you do not need such strict requirements, use fn mute or fn ones as bounds. Yeah, when you implement fn, you'll be forced to implement fn mute. That's true, but system is taking care. And if it's not passing any mutable reference, it will automatically call this fn call. Okay. Yeah, it's internal. Where is it? Extenders call. Okay. Uh, yeah, that's what that. And let's talk about function pointers. So if you have a function like add, which accepts x and y and return the sum, you can call it like this, and you can create a type binary operation like this, a function pointer type which accepts two parameters and return a I32. It's a type. So you can create add as a binom and bo, and bo you can call. So that's for that. Let's do this in the playground. Fn main and print x, println x. So now you can let control x. Let call. Oh, this should be mute. Only here. This you can comment. Yeah, 12. And if you want to do this, you can do it inside main control x, and let's do it as y, or just do someone and here sum2 and print sum2. So we are calling it in two ways, and both places we are getting 12. So this is a function pointer. This is shouldn't be confused with fn trait. You can see that fn is small letter f. Here closures traits are fn with capital F. It's a trait. This is basically a pointer. The unsafe qualifier indicates that, where is unsafe qualifier? Qualifier indicates that the type's value is unsafe function, and extern qualifier indicate it is an extern function. Okay, fn function type qualifiers with fn, bare function return type, function type qualifiers, extern. Oh yeah, like this. Extern rust. Extern rust default ABI. You write a normal fn view in Rust code. Yeah, extern C. This is same as extern fn view. Foo. Function within external blocks may be variadic by specifying the different multiple parameters as last argument. The variadic parameter may optionally be specified with an identifier. Yeah, link from different. Yeah, extend keyword also can be used with fn pointer. Yeah, that means external, some other C or some other language. The function won't be there. It should be linked from external. Yeah, binop is, in this case, binop is a function pointer. Yeah, when you are using type, you are basically creating a new type in Rust. Here it's binop and it's a function pointer. And if not this, where is that? Yeah, and if you violate this parameter count, yeah, unexpected, yeah, function takes two arguments but three arguments were supplied. It won't call, it won't compile at all. Yeah, see, yeah, this function pointer captures how many parameters and return type as well. So if your function is not returning, yeah, not returning u32, for example, let's do this. Yeah, u32, it should be i32. Yeah, that also will be captured. When you're calling, it can easily capture that. This one, right? Yeah. Yeah, that's what function pointer. So in this video we have covered super trait and closure types. Closure types are, yeah, fn ones. Closure types are all implement fn ones. indicating that they can be called once by consuming ownership of the closure. Additionally, some closures implement more specific call types. A closure which does not move out of any captured variables implements fn mute. A closure which indicating that it can be called by mutable reference. A closure which does not mutate or move out of any captured variables implements fn. If it's not moving value, then it's implement fn, indicating that it can be called by shared reference. Move closures may still implement fn and fn mute even though they capture variables by move. This is because traits implemented by a closure type are determined by what closure does with captured values, not how it captures them. Yeah, even though move is there, it still implements these two. That's why these are all super traits, right? If yeah, we discussed that fn implements fn mute, fn mute implement fn once. So everything will be implemented, but won't be calling that. This is because traits implemented by a closure type are determined by what closure does with captured values, not how it captures them. What it does with captures value. Okay, that's what that. Non-capturing closures are closures that don't capture anything from their environment. That can be coerced to function pointers fn. Okay, if non-capturing closures, this is a closure, it can be called and bind up, and this also will work. Non-capturing closures, yeah, if it's not capture, but it's capturing, right? Or don't capture anything, it's capturing, so this shouldn't be working. No output, why it's compiled. So let's do main. Let's do both. So what we do, x and y, should be given. Let it's not capturing anything. It's not capturing from environment. Okay. So we are creating a add function binob function pointer. Agree. It's an add. Add is this. So it should be at the top. Add is this. Add is a closure which get two parameters, but it's not captured from the environment, but it's passed as parameter. Okay, that's not capturing. And we are creating a binob function pointer, and we are coercing it because it can be called like this. Coerced. Add. Okay, this is agreed, and I want to print this. Print x xe, and let this also x, let it be y or someone sum1, sum2, println sum2. Oh, yep, 12, 12, good. Someone remove it. This is not mutable. That's true. We are not mutating this. 12, 12. Okay. Now, if I change this to let x equal to 5 and let y equals 6 and comma x comma y, what will happen? It shouldn't work. It's capturing value. Oh, oh, yeah, it's working. It's called as add x comma y. Yeah, let's do this. Yeah, let's do this. Maybe here is the problem. X comma y. Yeah, it's working. No problem. So it's not considered as capturing, as far as I understand. Where is it? Closure type. Non-capturing closures. I think move, moving is called capturing. It's copying. I think it's okay. Can be coerced to fn basically. Yeah, that's what we tested. I think that also makes sure uh, we have covered closure types, function pointers, and yeah, closure type and super traits. Yeah, I think that's all I need to cover in this video. Thank you all for watching this video, and we will connect in the next one. Thank you.